This is the second lecture in a two-part series on z-scores. Now, in the past, I've talked about the empirical rule for normally distributed data. What the empirical rule tells us is basically what probabilities, what areas are associated with different parts of a normal curve, like 68% of scores within one standard deviation or 95% of scores within two standard deviations of the mean, something like that. So let's say we have a random variable x, which is distributed like this. And I could ask you the question, like, what percentage of scores fall above 4.25? So really, I'm asking what falls within this shaded area. Now, in order to answer this question, we can calculate a z-score. We're going to convert that 4.25 into a z-score. So we're going to need to know x, we're going to need to know the population mean, and we're going to need to know the population standard deviation. Now, in this case, x is 4.25, because that's what I'm asking you about. What percentage of scores fall above that? And the population mean is 4. You can tell that from looking on the graph. 4 falls within the center. And you can also tell that the standard deviation is 1 because that's the distance between each standard deviation from the mean. So I can put all those things together and calculate a z. Just 4.25 minus 4 divided by 1. And we end up with the z-score of 0.25. What that means is that the score, 4.25, is about 0.25 standard deviations above the mean. So now that we know this information, now that we know that the z-score for 4.25 is 0.25, what are we going to do about it? What are we going to do with it? Well, with that z-score, we can actually find out what the area of that blue shaded area is. Now, instead of, using complicated calculus formulas or something to calculate the area, we actually have something called a z-table, which will show us all of the proportions, all of the areas associated with different z-scores. And it looks something like this. It looks very complicated, so let me walk you through what this table is doing. First of all, I need to talk about bodies and tails. In any distribution like this, when I draw the line to split things up, the bigger area is always going to be called the body, and the smaller area is always going to be called the tail. So like when you look at my z-table here, notice that it's always dealing with the area in the body. So if you look up any z-score, that's where you're going to find the area in the body. Other tables might also tell you the area in the tail, or they might tell you something like this, which is the area between the mean and z. So know what your table is doing. In our case, mine is just telling you the area in the body. So we have the z-score of 0.25. So if we go to the z-table and look up a z of 0.25, we'll find out that the area in the body is 0.5987. What that means is that the area in the body is about 60%. So I'm going to put that right there. Now remember, this is the area in the body. This is the area in the bigger portion. So what we're talking about is where I have these red arrows here. We're talking about that. And that's not what we're interested in. We want to know the blue area. We want to know what falls above 4.25. But remember that if that's 0.5987, the whole distribution has to add up to 100%. So what's in the blue area is just what isn't in the body. So it's just 1 minus 0.5987, and we get 0.4013. So the answer to what percentage of scores fall above 4.25 is 0.4013, or about 40%. And that's how we take a score, convert it into a z-score, and then use a z-table to find a percentage. So in this lecture, I talked about z-scores and the difference between the body and the tail.